This will be for the con exercise, probabilities of compound events. So just some brief notes real quick. Okay, this is for the number of outcomes when you must choose one from each group. Let's say you had groups A and B. That would be the number of outcomes in group A times the number of outcomes in group B. Okay, and you can extend this to 3 groups, 4 groups. You can extend this to anything 2 or more. Justin lives in St. Paul, goes to school in Minneapolis. In the morning, he has 3 transportation options to school, and in the evening, he has the same 3 choices for the trip home. If he randomly chooses his ride in the morning and in the evening, what is the probability that he'll use both the bus and the train? Okay, so let's write out the tree options for the morning. All right, let's just write 2 letters at a time. We'll start with bus, BCT. Bus, cab, or train. All right. So he can take the bus, and then the bus. He could take the bus and then the cab. He could take the bus and then the train. For the cab, he can take the cab and then the bus, the cab and then the cab and then the train and the bus, the train and the cab, and the train and the train. There's 9 possibilities, which makes sense because 3 times 3 is 9. What is the probability that he'll use both the bus and the train? Okay, so the probability of bus and train how many of them have bus and train? We have 1, 2. So that's 2 out of how many? 9 possibilities. All right, it's number of favorable divided by total number of outcomes, the basic probability formula. So that's it. It's just 2 over 9. All right, there's more than one way to write the sample space, but I didn't have enough room for the tree. So I suggest you write out all the options so it's easier to see the probability. You're having dinner at a restaurant that serves 5 kinds of pasta in 4 different flavors. If you randomly pick your pasta and flavor, what is the probability that you'll end up with something other than tomato spaghetti? Okay, so really all we have to do is find the probability of tomato spaghetti. Let me write this different. The probability of tomato spaghetti, and if it's something other than that, it's just going to be 1 minus that number, okay? Because in other words, we want anything that is not tomato spaghetti. So it's just going to be 1 minus that number. We're subtracting it from 100%. Now there's 5 pastas, 4 different flavors. You have to choose 1 of each. So the number of outcomes is just 5 times 4, which is 20. Okay? And for tomato spaghetti, that is just 1 possible outcome. So we have the 1 minus, and the chance of getting tomato spaghetti is going to be 1 out of 20. All right, tomato spaghetti is only 1 outcome of 20. I didn't want to write all of them. Maybe I will if I get a chance. And 1 minus 1 over 20, 1 is the same as 20 over 20. Minus 1 over 20, that's just 19 over 20. Final answer. 19 over 20. All right, I don't have enough room to write out all of the options. But like I said, 5 times 4 is 20. There's 20 outcomes, so that goes in the denominator. Tomato spaghetti is only one of those. All right, if you roll 2 fair 6-sided dice, what is the probability that the sum is 4 or higher? Okay, this one we're going to have to write it out. So we're going to need 6 rows and 6 columns. So the first roll, let's say that's a 1-1. And then a 1-2. And then a 1-3. 1-4. 1-5. And 1-6. So this is all the rolls when you roll a 1 first. Then keep going. You have a 2-1, a 2-2, 2-3, 2-4, 2-5, and 2-6. All right, the first number is the first roll. The second number is the second roll. Then you have a 3-1, 3-2, 3-3, 3-4, 3-5, 3-6. And you keep going. I'm going to write it out. You don't have to write all of them out. All right, but I'm going to write it out just to show you. All right, so 2 6-sided die. If you roll something with 6 options and then you roll the die again with 6 options, you're going to end up with 6 times 6 or 32 outcomes. And we want the probability that the sum is 4 or more. How many outcomes have 4 or more? Well, let's see. Right here we have 4 or more. So 1 plus 3 is 4. That's 1, 2, 3, 4. 4 or more. 5, 6, 7, 8, 9. And all of the rest of these are also going to be 4 or more. Okay, so this is 4 times 6. Which is 24, 25, 6, 7, 8, 9, 30, 1, 2, 3. 33 out of 36 will give you 4 or more. Okay, the only ones that won't are these right here. That's 33/36. All right, Marvin lives in Stormwind City, works as an engineer in the morning. He has 3 transportation options, and in the evening has the same 3 choices. If he chooses his method of travel in the morning, what's the probability that he teleports at least once a day? All right, so we have teleport, ride a dragon, or walk. Teleport, dragon, or walk. And in the evening, the same option. So teleport and teleport. Teleport and dragon. And teleport and walk. Dragon and teleport. Dragon and dragon. Dragon and walk. Walk and teleport. Walk and dragon. And walk and walk. I wrote out a sample space. Okay, 3 times 3 is 9, so there's going to be 9 choices. All right, so this probability here, the denominator is definitely going to be 9 because it's out of 9 choices. Teleport at least once a day. Which ones have teleport? Look for a T. At least one, so either 1 or 2. We have 1, 2, 3, 4, 5. 5 of them have teleportation. So it's just 5 out of 9. That's it.